Think of NAO as a friendly, pint-sized humanoid that grew out of a clear, deliberate research program. It was created by the French robotics company Aldebaran Robotics, founded by Bruno Maisonnier, as the flagship outcome of Project NAO, a multi-year effort to build an accessible, programmable social humanoid for research, education and public demonstration. The project began in the mid-2000s under Maisonnier's leadership. Aldebaran designed successive prototypes and released the first public NAO platforms to RoboCup teams and universities, then continued to iterate the hardware and software through multiple generations as the company became SoftBank Robotics and later reverted to Aldebaran. The genesis and invention timeline of NAO is straightforward. Concept work started around 2004, Aldebaran was founded in 2005, and early prototypes appeared between 2005–2007. NAO first reached the RoboCup Standard Platform League in 2007–2008 as the new standardized small humanoid for robot soccer, and production academic editions began shipping around 2008. Since then Aldebaran released several hardware generations: Next Gen, Evolution, NAO 6, now NAO 6, and the platform became widely used in labs and classrooms worldwide. At its core, NAO's main features and specifications are optimized for human-scale interaction in a compact package, roughly 57 centimeters tall and about 4 to 5 kg in mass, varies slightly by version, with 25 degrees of freedom (DOF) distributed across head, arms, torso and legs so it can walk, sit, gesture and balance, onboard microphones and directional audio, 2 HD cameras, stereo or mono depending on revision, tactile sensors in the head and feet, force sensors FSRs in the feet, sonar or infrared depending on configuration, an inertial measurement unit for balance, built-in speakers, Wi-Fi and Ethernet connectivity and an embedded controller with flash and RAM appropriate to the generation. Those elements together make NAO a mobile, talking, perceptive platform for research and teaching. Structurally, NAO is a compact humanoid skeleton made from a mix of engineered plastics and metal internal frames where strength is needed. External covers are smooth polymer shells shaped to be approachable and to protect internal electronics. Joints use small electric servo motors and gear trains. Places that need impact resistance, feet, lower legs, pelvis, use more robust composites or reinforced plastics. Batteries are swappable and housed in the torso, and the mainboard, cabling and batteries are arranged for relatively easy access in research versions. The design intentionally balances durability, serviceability and a childlike silhouette to make social interaction less intimidating. How NAO works, the practical mechanics and intelligence, is a layered combination of embedded control, sensor fusion, and higher-level behavior frameworks. At the low level, NAO runs motor controllers for each joint, the actuators with PID, trajectory controllers that keep posture and execute walking gaits, an IMU accelerometer plus gyroscope plus joint encoders provide closed-loop balance and posture feedback. Perception is provided by cameras, vision algorithms for face, object and color detection, an array of microphones for sound source localization and speech input, tactile sensors for touch interactions, and distance sensors for obstacle awareness. These feed a middleware and behavior engine that can run pre-programmed routines or higher-level code. NAO supports several programming interfaces: choreography, visual programming, Python, C++ SDKs and ROS wrappers in many labs, and modern NAO releases have been augmented with cloud-connected services and even generative AI tooling for easier conversational behaviors. In short, sensors, right pointing arrow. Perception, interpretation, right pointing arrow. Decision, behavior module, right pointing arrow. Actuator, commands. Developers plug in perception models or behavior scripts to make NAO perform tasks. Price and estimated cost have changed over time and differ by edition and purchase channel, but historically NAO was an institutional, research education price point. Early reports and vendor brochures placed units around €8,000, €12,000, roughly $10,000 United States dollars, $13,000 for research academic editions. Custom bundles, service support and teaching packages can raise the total cost of ownership. Because Aldebaran, SoftBank managed sales through distributors and included training, service options, institutions typically budgeted more to integrate NAO into labs or classrooms than the raw unit price alone. Note: prices depend on generation and support level and may change with company ownership and market conditions. NAO's country of origin is France. It was designed and developed by the Paris-based Aldebaran Robotics team, later branded SoftBank Robotics Europe during the SoftBank ownership period, and the platform remains strongly associated with French robotics research and industry collaborations. Looking ahead, NAO's future benefits and applications for humanity are visible in education, therapy and human-robot interaction research. As a reliable, child-sized social agent, NAO helps teach programming and STEM, supports special needs education. Autism therapy research has used NAO extensively, acts as an engaging training tool for language and social skills, and provides a reproducible research platform for robotics, perception and interaction studies. In healthcare and eldercare scenarios, NAO has been trialed for social engagement and activity prompting. In museums and public outreach, NAO serves as a demonstrator that makes robotics approachable. Because the platform is programmable and relatively safe to be around humans, it's a practical bridge between laboratory algorithms and real-world social use cases. There are also lesser-known or hidden facts worth flagging. NAO has been part of many creative, artistic and surprising projects, dance performances, stand-up demos, theater pieces, and its open SDK releases in the 2010s enabled a community exchange of behaviors and research modules. Conversely, like many connected robots, NAO has faced security and vulnerability analyses in the past. Independent researchers have demonstrated the potential for remote access to sensors or control if devices are not properly secured, which led to stronger firmware and network best practices. Finally, the platform's iterations, e.g., NAO 6, have kept software backwards compatibility in mind, which helped institutions preserve long-term investments in behavior libraries and curricula. Possible future developments and impact tie to two strands: technical upgrades and ecosystem evolution. Technically, future NAO-like platforms will likely integrate more powerful onboard compute for on-device neural models, better cameras and microphones, longer battery life, and tighter safety, cybersecurity by design, all of which will improve autonomy and natural interaction. Ecosystem-wise, coupling small humanoids with cloud AI, richer developer tooling, low-code, no-code conversation designers, and modular hardware options will push them further into classrooms, homes and care settings. However, the platform's near-term fate also depends on company and market forces. Recent corporate changes around Aldebaran, SoftBank have introduced uncertainty about manufacturing and long-term support, which could accelerate open-source community forks, third-party maintenance services, or successor products from new startups that learned from NAO's design. Regardless, NAO's lasting impact is pedagogical and cultural. It normalized small social humanoids as testbeds for interaction research, inspired generations of robotics students, and demonstrated practical benefits of robots that can walk, speak and engage with people.